So question 2 here is based on vectors. We've got two forces that are acting on a single particle, and we know that the resultant is going to be parallel to the given direction. We now need to find the value for Q. So let's start thinking about this situation. So I've got some P position. Let's say P is here. I've got some forces that I'm applying, so I know that I'm applying this force of 4i minus 2j, so let's think 4i minus 2j. So that's where one force is going to be. I know that the resultant force is going to be parallel to this vector, so I know that the resultant force is at 2i plus j. So the resultant force is going to be something in this direction. Now I don't know what the magnitude of that vector is. It could be any length indeed, but we do know that it is definitely in that direction. So that then helps me to draw on my second vector, which is going to be at 2i plus qj. So I'm thinking, right, so 2i and then some q amount of j, so that must be up here somewhere, so that when I compose my two blue vectors I end up with something on the red line. So my first vector plus my second vector will take me to some point on the red line because it's going to be parallel to this vector 2i plus j. So what have I done here? Where I've taken my two vectors, the first vector being 4i minus 2j and the second vector being 2i plus qj, all I've done to start with is added those vectors together. So let's just make it clear here that we're answering part A, and the first thing I'm going to do is to add those two vectors together. So 4i minus 2j plus 2i plus qj. What does that give me? That's 6i and then q minus 2 lots of j. And what do I know? Well, I know that it's parallel to this vector, which we had out here in red. And if this is going to be parallel to the vector 2i plus j, it means that there's some scalar multiple. So this vector here is just some scalar multiple of 2i plus j. That is, that I can write 6i plus q minus 2j will be equal to some scalar multiple of 2i plus j. Now by comparing the I coefficients, I can quickly work out the value for k, and it's easy enough here to see that k is going to be 3. So to get this resultant vector I just need to do 3 lots of this direction. Now I can compare the j coefficients to say that q minus 2 must be equal to k times by j, which is going to be 3, so that is that q must be equal to 5, and there's my answer for the first part of this question. The second part of this question asked me to look at the following. Time t equals 0, it's moving with this velocity, to find the speed at the time where t is 2. So I've been given in here an initial velocity, I've been given a time, and I want to find a final velocity. Now let's go through this question again, because I'm told about something to do with forces, and I'm told about something to do with mass, and obviously where we're looking at force and mass, we should be thinking that force is equal to mass multiplied by acceleration. Or in vector form, my vector force is equal to mass multiplied by acceleration. Okay, so let's write down what we've got involved here. We know our u value. The initial was given to us in the question, which is minus 2i plus 4j. We want to find our v value. We can calculate the a value, and we know that t is 2. Now in order to calculate this a value, we need to know F is equal to m multiplied by a. We knew the force because the resultant force was just what we had found out in this previous question. The resultant force was 6i, and then q worked out to be 5, so 5 minus 2 is plus 3j. And that's going to be equal to the mass, which again we're told in the question, 1.5, multiplied by the acceleration. So now, dividing through by 1.5, I get 4i plus 2j as my acceleration. And I can go ahead and stick that straight in here, 4I plus 2j. Now, time to finish the question using one of our Suvat equations. So in this case, I'm using v is equal to u plus a t. To find that final velocity, I need the initial velocity, which is minus 2I plus 4j. And I need the acceleration, which is 4I plus 2j, multiplied by time, which is 2. So my vector v is going to be minus 2I plus 4j plus 8I plus 4j, which gives me 6I plus 8j. Now, it would be a foolish thing to stop at this point thinking that I had found the solution, because the question was asking me to find the speed of p at time t equals 2, and what I found at the moment is the velocity. So what I need to do now is to find the magnitude of the velocity so that I can find the speed, which is going to be 6 squared plus 8 squared square rooted. And we should hopefully recognize this as being nice Pythagorean triple, so we get an answer here of 10. Looks a little bit like 16, but it is definitely 10 meters per second.